So taxes are a different kind of structure, and rather than having a simple yes-no, there's graded levels of penalty or reward. The rewards would be rebates, or feebates are sort of a mix of taxes and rebates, so fees being the tax part and bates being sort of the second half of rebates, so that you can tax some companies and reward others at the same time. So for instance, the worst emitters of a particular pollutant might get taxed heavily for it, but the best emitters might actually get money back from the government as a reward for doing well. So these graded levels of penalty and reward tilt the market's playing field so that it can help internalize the external costs that just sort of go out to the public commons. So taxes are usually static. They're usually set at a certain, like $5 per ton of CO2 or whatever. But they can be dynamic. You can write it into the law that the tax rate will be such and such for the first few years, and then it'll go up to something else after that, and it'll go up to something else after that. But they're usually static. The good thing about taxes and potentially rebates and feebates if they include taxes, is that they can fund their own enforcement because companies are paying money. And so that can be a very sustainable funding model for these laws. And they can even offset other taxes. Many people have proposed carbon taxes offset payroll taxes or employment taxes. A couple downsides of these are that nobody likes taxes, and that there's no hard limit on how much pollution can happen under this. So basically, companies can keep polluting as much as they want as long as it's cost effective for them. And that's how cap and trade systems are different, because basically they set a hard limit on how much of a particular substance can be emitted, and then the market decides how much it costs. So that again tilts the market's playing field, so it internalizes the externalities, as they say, because it's an auction system. So there are allowances for emitting, say, sulfur dioxide or carbon dioxide or whatever substance, and those are put up on the auction block, and whoever pays top dollar gets so many credits. And what's more, companies can buy and sell credits from each other. So one company that's particularly good at reducing its emissions can make money off the fact that it's done that by selling its allowances to other companies that are not so good at reducing their emissions. And this helps drive innovation as a result, because it creates a market for carbon reduction or sulfur dioxide reduction or whatever the pollutant is. And because this is not setting a fixed monetary amount on the emissions, it puts some volatility into this marketplace. And that actually creates an additional incentive for businesses, because businesses are generally very risk averse. And so in addition to the financial costs of the emissions, whatever it is, there's also the risk aversion because of the volatility. Now, cap and trade can be done well or it can be done badly, and there's varying degrees of success out there in the world. Generally, what people say is that good cap and trade sets tight caps, so the limit is a hard limit, and companies can't just apply for exemptions to emit more than the total. And emissions are measured in good cap and trade systems. So the current EU system of greenhouse cap and trade, they estimate emissions rather than measuring them. Whereas the US EPA 1990 addition to the Clean Air Act, where they set a sulfur dioxide cap and trade system, there they required companies to actually measure their emissions. Good systems are comprehensive. That means they cover all the major sources of emissions. So it's much more effective to have a worldwide cap-and-trade system for greenhouse gases than it is for just one particular state or one particular region. And no free credits. This is something that most cap-and-trade systems have violated, is that they let the big entrenched players with a lot of government influence get free credits rather than having to pay for them. And obviously that defeats the purpose of the system. And good systems don't allow external offsets. For instance, the EU greenhouse cap-and-trade system has come under criticism for allowing offsets from companies that help fund the building of hydroelectric dams in China, because those dams were going to be built anyway, and so it's not actually offsetting any emission. It's not replacing any CO2 emission that would have been happening. And one consideration that there's some debate about is whether to do cap-and-trade upstream or downstream. So upstream is you would put the cap-and-trade on electric power plants and fossil fuel sellers or oil companies and the like. Whereas downstream, you would put the cap-and-trade on every home and business's individual emissions, which is basically just a lot more hassle to administer, because suddenly you have millions of players that you need to track rather than a few dozen. But some people in the green building world have made a strong case for allowing downstream offsets of emissions, namely allowing efficiency measures in green buildings to be sold as cap-and-trade credits, basically to be sold as offsets that upstream companies, oil companies or electric power producers, could buy. So for designing good laws, I'm going to put forth a few considerations here. One is the prescriptive versus performative thing that I mentioned a little bit ago. Prescriptive laws give you only one right way or only one wrong way of doing things. Things like don't use lead in solder, or requiring a particular kind of emissions control technologies on smokestacks so that it reduces sulfur dioxide emissions. Now, that can be very useful. It's certainly very simple to determine the compliance, but performative legislation instead allows companies to do whatever they want as long as they meet a certain criterion. And it's really measuring the end goals rather than a particular strategy. So, for instance, with the emission controls on the smokestack, a performative legislation would say you have to have sulfur dioxide emissions below this certain threshold, and it doesn't tell you anything about what technologies you need to do to get there. And in the long run, this is more useful because it allows more innovation. If someone invents a new scrubbing technology that's more effective or less expensive for the same effectiveness, then that can be put in place. And sometimes they can still be easy to measure as well. In the case of sulfur dioxide emissions, that's a pretty easy thing to just measure in the emissions. So the next consideration in designing good laws, I would say, is emergent properties. These are complex patterns that can arise from simple interactions, and it's something that comes from chaos theory. You're probably familiar with it, though, as the law of unintended consequences. Things like Cabrini Green, which was this housing project in the Chicago area, which it's a great idea to build affordable public housing for people who are too poor to afford market rate housing. Very good intentions, but then what ended up happening is that Cabrini Green became the murder capital of the world because it ended up having a lot of gang activity and drug activity and things like that. And so something that was built with the best of intentions had terrible unintended consequences. And that can happen with any law as well. So, unfortunately, there's not yet a general theory of how to predict emergent properties from, from simple rules, but we can do simulations. That's usually what people do in chaos dynamics, and this allows you to at least do some trial and error to figure out non-obvious consequences so that you can plan for them. You can design a system that will hopefully create better consequences than others might. Another consideration for designing good laws is game theory. This is a branch of mathematics that can give you quantitative probabilities for the decisions of actors in a system that is that's interdependent. The most famous one is the prisoner's dilemma. Look it up on Wikipedia. And game theory basically applies to any kind of situation where you have people playing by certain rules. And that's basically what's happening when industry and legislation come together. And designing good rules to the game can make the players act in the ways that you want to. And once again, these might not be obvious at first, but if you map out the system like game theorists do, it may give you insight and may help you to design better systems. And finally, the last piece of advice I would say for designing good policy is that lawyers should be programmers. They're both writing code. One is legal code, one is programming code. And programmers are basically taught to build very, very tight code because if something doesn't work in a software program, the code crashes instantly. So it forces a level of intellectual rigor and a clarity of thought that that doesn't happen with most lawyers, because in the law, if your code crashes, basically, that means that it causes an argument. And that often happens 10 years later with people entirely different from you doing the arguing. Or, is a loophole that never gets fixed. Things like that. So I think that a lot of the structured thought and clarity of thought that comes from programming would be very valuable to policymaking as well. So that's it for the stint on environmental laws. Now, environmental labels are very similar. Like I said, they're basically just a voluntary version of environmental laws.